everybody to our session 1A on connected autonomous vehicles. We have three great speakers over two speeches this evening. Our last session before dinner. Look forward to it. Whenever it comes time to do the technical committee of whatever I'm doing, I always pause. I don't want to be a moderator hog, but whenever opportunity arises to moderate the connected autonomous vehicle session, I jump at it. That's my passion. I've been following it for over a decade. I'm very interested in it. I love to hear what's going on, and it's been a lot of change. It's happened. There's a lot more change that's going to happen, and we're going to hear about that in these next two presentations. When you go ahead and introduce our first speakers, we have two speakers. They're going to be talking about the GDOT CAV program across the state. We have Justin Hatch, who's a graduate of Georgia Tech. He's worked for GDOT for 10 years. He spent time in District 5 and District 7, the Traffic Operations Office, as well as State Traffic Operations Office. He currently serves as the Assistant State Traffic Engineer, leading the state's signal operations and maintenance programs, as well as advancing the state's connected vehicle goals. He's a proud husband and father to son Henry and daughter Ruth. We also have Alan Davis. He's currently our State Traffic Engineer at GDOT. Previously led the department's traffic signal operations program and efforts in connected vehicle performance and applications. He's a registered PE in Georgia and South Carolina and a PTOE. Serves as a member of the Signals Technical Committee with the National Committee on Uniform Traffic Control Devices. Graduate of the University of South Carolina. I'm going to present Alan, thank you, speak, and then Justin. I got it. And then this is for virtual. So they can hear me, nobody else can. All right, I'll try to project for you all since and the house mic isn't working, but hopefully you can hear me all right. Happy to be here. I'll be joined with Justin Hatch here towards the end of the presentation. I'm going to talk a little bit about where the program has been and kind of the national perspectives on things. And then Justin's going to take us down the road of where we see the department going with V2X and connected vehicles. So without further ado, I'll jump right into it since I know everybody's probably a little hungry for dinner. Just to give you a perspective of what we're talking about here with connected vehicles, I borrowed this slide from our friends at Toyota. This was the breakdown of dedicated spectrum for connected vehicles. This just shows some of the channelization that was in there of how different messages and things are broken out there. Just to raise the point that back in 1999, Congress allocated or directed the FCC to allocate a dedicated portion of spectrum for connected vehicle technologies. The idea was that this dedicated space could provide open access to connected vehicle messages to improve vehicle safety and for ITS applications. And this was the result of it. This was the old DSRC breakdown of where those message sets would break down within it. So I mentioned 1999 and the timeline to get this is from our friends at Toyota. This stuff's been going on for a while. So, and I think I want to raise this point that the work and effort that's been going on here is not something that has just been a snap of a finger, turn it on. We've got over a decade of standards works, technology research, and implementation for these safety of life applications that need a lot of work to make sure you get it right. So just gives you a timeline of things that are going on. And there's a couple things in here too that I'll point out with FCC. They're highlighted in red to say that if you've been following this space in any regularity, you've known the FCC has been acting in this space to modify or change the spectrum, especially as of late. But that's been going on for a long time. Back from 2013, wireless spectrum, I'm sure you all know, is a very valuable and scarce resource. The auctions for these bands of spectrum that go off today are for billions of dollars. Now, we only had, in the past tense, 75 megahertz to work with, and that's now been cut to just 30 here recently. But there's been a lot of work from the FCC side and folks wanting to grab hold of that spectrum for other uses for some time now, which has made realizing the benefits of connected vehicle deployments and safety improvements from that technology a real challenge to have it always there. That all said, I'll get a little bit into talk about radios here just to level set where we are. A lot of people will talk about the specific technologies that are used in connected vehicles. Is it DSRC? Is it Wi-Fi? Is it network cellular? Is it C-V2X? Is it 5G? Is it 10G? Whatever. We've had a bit of a perspective here where we want to focus more on the common elements of connected vehicle technology so that we can be prepared for the versatile side of it, the different radio types. We're working on the things that will support ubiquitous use of our information as an infrastructure owner operator to support these things, whether it's this radio, that radio. We want to stand in a place where we're ready for where market and industry take us. So just to separate those out there, your common side is the applications, the things that are making things work. And that wireless interface, just the radio, is just one part of it. Just to that point, we've arranged our network and infrastructure. It's an example of the data that's coming out of something like a traffic signal. To have a framework that's ready to go either directly to vehicles over this dedicated spectrum. Those are what we call our more safety automotive grade data, where it needs to be there and less sub 100 milliseconds, sub 25 milliseconds, virtually zero latency for these safety applications. And then there's other applications out there. We'll call that mobility or information data that needs that information where it's not necessarily time sensitive. It can be a few seconds old. It can be a few minutes old. We want to be ready to support all of those applications as an agency. So to that end, we have prepared our infrastructure by deploying a large number of RSUs. This has been through a number of different partnerships with local governments, NPOs, federal grants, and our own money as well to build out this infrastructure. And so where we stand right now, we have over 1,000 RSUs deployed across the state just through our efforts and those partnerships I mentioned. Largely based in Atlanta, but we do have some branched out to Savannah and as well as in the western part of the state over towards the Grange. And we've been focusing on leveraging these right now as we wait for private sector vehicle deployments, leveraging these in public sector fleets, things like emergency vehicle preemption, transit signal priority, emergency vehicle preemption. And again, Justin's going to talk a little bit more about what that looks like in reality in a minute. Just to focus on those applications that we have enabled that are stood up, we took these things from pilot and taken them to a place where we would call them production ready. Emergency vehicle preemption, emergency vehicles get immediate green lights, transit and freight priority, signal priority where you get an earlier green or a later green depending on certain conditions, and lots of signal phasing and timing applications that are leveraging the information coming out of a traffic signal controller in these standardized formats to deliver some type of application to a vehicle. We'll zoom in real quick on some of the actual pilots we did stand these up. We work with CERTA to demonstrate transit signal priority. They wanted to see if it was a timing strategy and operational strategy that would bring them better reliability to their transit services. We wanted to make sure that our infrastructure would work and support it through connected vehicle infrastructure. It was a success from both fronts. We did improve reliability for Express on one of their least reliable routes. And we demonstrated that this was a feasible interface for applications like transit signal priority in the future, and something that we could scale out on a regional basis. Looking at freight signal priority. So operationally, it's kind of the same thing as transit. You send this request to the infrastructure and then get granted either an earlier or late green if your operational parameters allow for it. We demonstrated this down in Savannah, wanted to see if there were things we could do with freight. We also looked at what we could do of providing traveler information to vehicles if there were blocked crossings, at-grade crossings going in and out of the port. Always looking for opportunities that we can improve freight mobility and safety. This is a great way for us to demonstrate that with some partners down there. I'll also talk a little bit about the work we've done with the Ray out on I-85 in partnership with Panasonic and Kia Georgia as well. We have two phases of a project out there, one focused on interstate-based applications. So we demonstrated things like queue ahead, traveler information within a work zone, spot weather warning type applications, all aggregated up through Panasonic's Cirrus platform that's ingesting all these messages coming from vehicles on the road that we're able to gather and producing those kind of actionable information thing for us, providing those alerts back out to the public directly based on real-time conditions on the road. We took that whole project a step further in partnership with Kia Georgia and actually outfitted 10 of their executive fleet vehicles at the plant out there, and have been doing some work on freight signal priority with them at the intersections along Kia Boulevard. It's a fun project. It's cool to see some of these mature elements of industry come together in like the Panasonic platform, and the partnership we have with Kia and the Ray out there has been great to see. But lastly, and before I hand over to Justin, I want to just give a little level set of where we are too with the FCC. I like to call it, we're kind of in this, the already but not yet. We're in a place as industry, both on the infrastructure owner operator side as well as on the automaker side, where we realize the benefits of connected vehicles, what it can do for safety, what it can do for mobility, and we all stand ready to deploy it. But there are regulatory actions that stand in our way. We, even now in the state of Georgia, have been waiting since September 2021 on a waiver approval to turn on our CV2X devices. It is March 2023. We've been waiting since 2021 on just a waiver approval. It's been frustrating. It's been a huge challenge, but we still stand ready. We see the benefit. We see the demonstration, the scalability, and the implementation of this technology and what it could do. But we're not yet there to a place where we can, or where automakers can commit to an investment in their infrastructure to deploy vehicles. You know, what's the big deal about a waiver, you ask, and why is it? So all this operation in the spectrum is dependent on federal regulation, and it's the FCC's jurisdiction to govern that spectrum. And so they're making sure at this time that what they approve is not going to interfere with other things. One of the big obstacles to that is military radar. The spectrum that we use for connected vehicles is shared partially with military radar installations. And one of the waiver requests from other organizations for the operation of CV2X radios is at a power level that gave the Department of Defense a little bit of pause about allowing it to operation. I suspect that recent events of things traveling over the US maybe gives them even more concern about whether their radar can not operate without any interference. So to a certain degree, I certainly understand it, but you know, we have a safety problem on our roads today where we need to do things to improve safety for users. Connected vehicle technology is one of those things that will do it, and so we still stand ready to deploy. On that light note, I will hand it over to Justin to give a little bit of view about what our roadmap is moving forward in light of all these things. So Josh, oh yeah, the mic. You know what? They might want to listen to my comment.
We definitely did not discuss that transition at all. Interesting choice there, Alan. All right. So I've been in my current position for about a year. If you're newer to this topic or been here for a while, I always find it interesting to speak on, especially alongside Alan. A lot of this, you know, if you saw the 1,200 plus devices that on that map that were deployed, a lot of that was going on in my backyard while I worked out of District 7. And so, I mean, if it seems new and like there's a lot going on, there is quite a lot, and we've gotten quite far with existing pilots. And I find myself in a very lucky position to now stand on some shoulders and carry those programs forward, which is definitely a lot of work and a lot of history, but fortunately, we've got a lot of exciting stuff we're working on out of our office, at the department, statewide, with other agencies, to make it very easy for me to just kind of pick things up. We're not doing pilots anymore, we're doing deployments, which is very cool for me and for the teams. So just, I'm gonna highlight a couple of those projects that we're focused on at the moment. The first, referred to as ITS for Us, and the first couple of these are both federal grants, supported by federal grants. ITS for Us is a US DOT grant through their ITS Joint Program Office. We're partnering alongside ARC, Gwinnett County, as well as several others in this project. It's very cool. It is going to support mobility solutions for all roadway users, but it also, it's targeting in particular disadvantaged or underprivileged roadway users. So there are those with physical or cognitive disabilities. There are those who might be elderly, a few others I'm going to forget on the spot, but that's kind of the idea. And it's also to provide kind of a end-to-end solution for roadway users. And so you can do pre-trip planning with with this project, we'll assist with pre-trip planning. We'll assist with like kind of direction by direction turns. It will also help someone, say, arriving at a transit agency and traveling outdoor to find their bus stop that they might be trying to reach, as well as ultimately reaching a destination at, say, a government building and getting them to that door. And so it's really, again, trying to drive mobility solutions for those who we aren't currently providing them to. ATC, MTD, oh gosh, Advanced Transportation Management. I should know it, and I don't. I'm sorry. But this is another federal grant. GDOT's a little bit more out in front on this one, but again, partnering with ARC as well as several others. The idea behind this project is very much leveraging existing technology that's already been deployed. You saw the kind of some of the Midtown maps and where we've already done TSP, transit signal priority in Atlanta. And so there's leveraging that technology as well as deploying some more, but what it's really focused on is pursuing some additional applications with emergency vehicles that are past that pilot, but hopefully more into a deployment stage. So we're going to be deploying equipment in hero vehicles as well as ambulances, and so and targeting specific intersections, primarily at ramps, but also key intersections in Midtown that'll help hero units provide a faster response to emergencies on the interstates, as well as help ambulances get down to Midtown Emory Hospital. Another really cool one, there's a little police officer hat there, and so if you're familiar with operations around One Georgia Center, there will actually be someone with a mobile device, hopefully getting a notification, or by design getting a notification from us, letting them know that a vehicle is coming, at speed with priority, so that they can assist with keeping the road clear of turning vehicles. So those are just a couple of projects. We've got several TSPs, transit signal priority projects that we're pursuing at the moment. The one I'm most excited about is not far south from here in Savannah, partnering with Chatham Area Transit, CAT, and they've got 2 priority corridors that they identified that they just said they really want to be out in front on TSP solutions for, asked what we could do. And so we're going to start partnering with them quickly to deploy both roadside units as well as onboard units for those buses, and start providing priority similar to that development in Midtown, but not a pilot, hopefully a long-term installation, and really is going to showcase what we can do for all agencies, all transit agencies as well as cities in the state, with frankly not a lot of new technology, technology that's out there, that's deployed, that's proven. We're also pursuing, going to be assisting MARTA in Atlanta, and the same with their ART and BRT projects that they've been outlining moving forward. And so we're talking to them about Summer Hill primarily at the moment, but going to be trying to develop that. Obviously, they've got a broad ART, BRT program that they're pursuing, so we hope to assist with that. Finally, and really what all of this amounts to is carrying forward GDOT's vehicle to infrastructure roadmap. And so that started as a document that was written, I think, in October of 2021. Alan likes to point out how quickly it's already gotten behind in just those 2 years. But from that document, or as part of that document, outlined is a 10-year spending plan. And so that's about $7 million a year, 75 over 10 years. That we have identified. Again, some folks did a lot of prep work for me and just laid this in front of me so we can run. But with that, we plan to deploy to the rest of the 6,500 plus state route intersections across the state. We can actually assist local agencies as well with off-system routes, so that we can enable, say, not just transit signal priority, but other connected vehicle applications as well. A couple of highlights from that document, though. We're trying to focus on our own, and all that to say is, these challenges with the FCC, challenges with not quite knowing where technology is going and when OEMs will be doing what. We can focus on our own fleets, our transit vehicles, our emergency vehicles and heroes, possibly assisting local agencies with their emergency vehicles, such as a fire engine, and giving those folks applications immediately today while the rest of this gets caught up in the industry. But also enabling, whether it be a traffic signal or another roadside unit, to be there and ready to go when private applications are there. A couple other highlights, I always forget, I'm sorry. From that roadmap, we definitely want to hedge technology as we continue forward. Certainly, RSUs and OBUs are really the big focus, the two acronyms you're going to hear a lot, but we're trying to remain open, as well as invest in open data portals. And all that to say, it's going to support future industry needs that we may not see yet. But by providing that open data and supporting those portals, we should advance this, or allow this technology to be advanced more quickly. And so just GDOT's vision for the state, again, assisting transit, assisting freight. So there's a pilot down at the ports as well that was completed, assisting emergency vehicles. All of this is possible. I mean, it does lean on smart signal technology, which has been deployed going on, I think, 8-9 years now in the state. All of that really does build on this. A lot of states who are looking at this have to look at upgrading their traffic signal controllers or adding another device to provide additional processing. So it's very cool that GDOT can lean on that in our controllers, but we can also lean on that technology to assist all those modes of operation and priority and benefits interoperably. We don't need multiple devices for multiple applications. And again, we can do that cross-jurisdictionally, and so you don't run into some issue where, say, a regional ambulance provider needs to get to another location but loses the ability for priority. If we kind of do this the way GDOT has envisioned, Georgia has envisioned, you should not run into issues where you simply cross into a new jurisdiction and have an issue. That yes and approach to technology, again, RSUs and OBUs are what we're focused on today, but looking to make sure we stay open to other solutions. And then again, focusing, the primary benefit of a lot of this for us is safety benefits. There are certainly other applications for connected vehicles, but that's our focus at the moment. So finally, this was kind of, baked from or boiled down from another presentation that we gave at summer seminar, but it kind of, the point of that presentation was kind of a call to action, but there is a need for better. Alan and I probably struggle to get outside of the signal applications when we talk about this, but it does go across, connected vehicle applications in the industry in general. But there is a need to do the daily things that we do as traffic signal owner operators, but also other infrastructure owner operators, designers, planners, to just do the day-to-day better in order to enable connected vehicle applications. And so, at least for me, stepping into the connected vehicle space the first time, I certainly kind of saw is there a need for this? Aren't autonomous vehicles potentially going to solve all of the problems we're trying to solve one day for us? The answer is not quite. There is a potential for connected vehicles that's been studied to have the potential to reduce crashes by up to 80% across the board. For that to happen, OEMs have told infrastructure owner operators like those in Georgia that they need additional information from us. That might be information that they can't gather on their own, but also is quite a lot of information that they want to have redundant feeds on. And so, yes, they might be able to interpret what a signal is saying, but they might have trouble some days and want a certainty that that signal is red or green from us. You can see kind of a list of some of the data points they're trying to get, things you would expect. So, confirming your GPS location if it's off ever so slightly, because that would affect whether or not you are making a left turn or you're going through a signal, and what your car might tell you, what feedback it might give you, but also some things you might not expect, like ambient temperature and roadway temperature. And so if we as infrastructure owner operators are not able to provide that information reliably and consistently, then those applications or potential applications, life-saving applications, might not be effective. And so one good example is traffic signals are kind of quite a resilient device, really, all things considered. You very much can lock up a cabinet and let it run for 10 years, and certainly some folks do that in certain cases. But if we do that and we don't maintain operations and timing as well as we can, then the applications that rely on that data to tell a driver that they're about to potentially approach a red light at speed and thereby violate that red light, they might not be able to provide that driver, in a 1 second here or there, they might not be able to provide that driver reliable information on when that light's turning red. And so it's very, very critical that those across the industry understand those life-saving applications and what role they play in that application working appropriately. Yeah, so that's all I got. Questions after?
Yes.
No.
Yes, I'd like to open up the floor to for Alan and Justin.
I think Alan did this, so I would have to answer the questions. The DSRC is 5.9 gigahertz band, and that's the band that the FCC has been looking at downsizing. I'm not sure. I just refer to the other band as cellular V2X. I'm not quite. It's all 5.9. Excuse me, 5.9 gigahertz.
Tracking the virtual questions.
Looking for the chat now. I see no questions.
Okay. Oh, you're tracking that. Thank you. Yes.
With all of our potential new manufacturer programs, vehicle, or anything that brings synergy, all those manufacturing facilities.
Yeah.
Thank you, Alan.
So you mean synergy with us and the automakers, or
Yeah.
amongst themselves?
Well,
All the other. So I'll say this. Traditionally, for over 100 years now, DOTs have built roads and operated them and maintained them, and automakers have built cars that ride on our roads, and we didn't talk to each other. And it's been pretty fascinating in this venture to start those conversations with them and have a better understanding of one another, of what our needs are. So we serve on a number of different national groups and organizations that have brought a lot of those conversations together. A lot of the research that we do, one of the slides I had up had a group called CAMP on it, which is a, oh gosh, I don't remember what it stands for now. Crash Avoidance Mitigation Partners. So it was a consortium amongst automakers of ways to leverage this technology for the purposes of reducing crashes. So historically closed groups that, they took each other's cars apart to reverse engineer them. That was their interactions with one another. Now they're working together with their people to deliver consistent uniform applications. And we're engaged in that now too, for the piece that they need from infrastructure to make these things work. So that synergy is going on. I mentioned we are working with Kia Georgia on our partnership out there, ways we could work together to understand their needs better and the way the state can stand up for it. So there is some of that conversation going on as well. And to be honest, we look for those opportunities every day that we can, where it makes sense for us to talk, to create, to deploy, whatever it may be. One thing we do know for sure, though, is that they do have a reliance on our information. They have very high standards on the quality of the information they get from us. They're deploying systems that are going to control the movement of a vehicle. So they want to make darn sure that they get it right, and that what we're sending them is right. So there's been a lot of conversation around trust there as well. So there's been a good bit of it, yeah. And I probably would venture to say more than there's been in 100 years.
Yeah, I'll take one more.
So, I mean, a lot of the data that we're talking about are like standards within the CV or the CV space, but like a basic safety message. I'm gonna forget all of them. I'm up here on a podium, but I mean, there are standard messages that go around, but it's not particularly passing any information that we can't provide already. And so, I mean, I'd have to know what you were looking for, but like our ATSPNs, automated traffic signal performance metrics, is an attempt to provide a lot of the data that frankly is contained within these messages if you're looking for something else. But that's GDOT, that's a separate presentation that's been done many times. But We can provide you a link to those platforms. And if there's some other data, you know, again, GDOT's, yes, very much trying to provide open data sources. So the answer is yes, but you probably you don't have to go like drive out a connected vehicle to get that information. Yeah, and so sorry.
There's the data.
Oh, yeah. There is a data portal. There's an API running on our traffic signal ATMS platform that allows the capturing of that data. If you're looking, yes, to run metrics in general around signals and analyze it for whatever purpose, such as what you're saying. I mean, that's what my team does every day, or is supposed to be doing every day. And we can provide that data to you, yeah.
Thank you very much. And I have a gift of appreciation for the two of you.
New car.
Attempt to change this over. See. See. Our second and final speaker today. Over here where you hear me a little better. Xuewen Lee is a transportation engineering professional, more than 20 years experience in engineering consulting. Managed a diverse set of transportation engineering and ITS planning and design projects. His recent practice has been related to emerging transportation technology implementation. He's currently working with Jacobs in Atlanta as a senior project manager. Got an MBA from Georgia Tech, a master's in civil, actually in transportation engineering from South Florida, bachelor's in civil from IG University. He's going to be speaking on autonomous vehicle, AV shuttle service deployment. So Xuewen, here's your.
So some of you probably remember last year, IT hosted a technology challenge and identify some emerging mobility solutions to accommodate aging populations. And the AV shuttle service was identified as one of the potential solutions. So today I want to use the opportunity to elaborate a little bit more related to AV shuttle service deployment using a project we are working on right now with Cumberland and CID. So I'm going to provide an overview of the project with Cumberland CID, and then zoom out a little bit, talk in general, what are the challenges associated with AV shuttle service deployment and some of the general characteristics and what's coming up in this field. So Cumberland CID is developing a 3-mile loop called a sweep, trying to connect the major properties in the district. So on the right-hand side of the map shows the alignment, the 3 miles. The main objective is to improve the walkability and the safety in the district to accommodate bike paths and also provide autonomous shuttle services. The color of the map divided segments into 6 segments. A, B, C, D, E, F. So each segment has its own unique characteristics and the challenges. So that's why they are trying to separate out. And also another challenge we can talk about is how they can actually implement it. They're potentially likely by a phased approach, mainly because the funding challenge they're dealing with. So our scope is to help CID. One is to help them navigate is an emerging technology, right? It's a lot of unknown. So what are the available technology provider? What is the state of practice in the field? And also from an engineering perspective, evaluate the alignment. Even though they have envisioned that's the alignment they want to go forward, but what are the risk challenges with this alignment in order to accommodate AV shuttle services? And what about funding? What are the opportunities they can go with, apply to locate some funding? And towards the end, when they're ready, we are going to also support their procurement process. Right now, we just finished initial ridership analysis. It's part of the process, working with the stakeholders, understand what are potential trips coming and what are the connectivities this service potentially will provide. Going backwards. A lot of you probably familiar when we talk about AV shuttle service, autonomous driving. Is more the target is for level 4 automation. So right now we know it's not there yet. So there are a lot of deployment in the US, but there are barriers right now is preventing that type of operation get to level 4. One thing is related to what Alan and Justin talked about is at the signals, what do they do? So they right now most of deployment they are not using connected vehicle technologies. Actually, we got an opportunity early this February asking one of the OEMs why they still sticking with cameras. One thing right now, we already got a sense, CV technology is not a plug play, right? And also another interesting perspective I got is it has a cost components to it. If they have to incorporate CV technology means they have to get another cost in their software package. So most AV shuttle operation right now is running at level 3, rely on some limited user input. So first deployment in the US started in 2016. Since then, there are about 70-something deployment in the US. In the metro area, some of you probably tried out the AV service at the Cedar PG corners. So they are the first one in the metro area and running this AV shuttle services. And overall, the investment in the AV shuttle development in the US is very limited comparing to the investment the company's business are investing in AV driving systems. Throughout the world, they are, if you count major providers, shuttle providers, about 25 of them, 7 of them in the US, and one of the popular ones, Local Motors, they have an operation in the Knoxville, Tennessee. They closed their business over a year ago. So because it's emerging technology, so from business perspective, it's also a challenge space. So some general operation characteristics associated with AV shuttle service at this time. So it's fully automated traveling on the defined path. The environment is designed environment. Equipped with various technologies, many LiDAR, camera. So you probably heard of to make the vehicle capable of detect conflict, vehicles, pedestrians, or cyclists, and typically come with real-time monitoring or tracking capabilities. And all of the deployment right now, they come with real-time tracking as part of the operation in case something happens. And typically in a small fleet deployment, and they can operate without and with a driver or attendant on board. That depends on where the operation is at. And so far, most of them are not collecting a fee. So some general specifications, as we know, is an emerging technology. So the technology aspect is changing. So with general vehicle dimensions, passenger carrying capacity, most of them are electrical vehicles. So you care about their charging battery capacity, how much time it takes to charge them, and what are the grade limitations. So later on, you will see one of the things, or most common complaints related to this type of service is the running speed. So you can see the operation speed right now is 10 to 15 miles per hour. But we will see in the coming models, it's going to dramatically change that. From engineering side, that's engineers, we care about what are the things associated with AV operation. Overall, the environment the AV is running on, we call the operation domain. So all this area, we call the operation domain design, can be roadway related, it can be pavement, or it can be the vehicle travel speed, the shuttle essential if it's running into mixed traffic, can be related to weather condition or your operating schedule. So all these things constrains the AV operations from a vendor or provider perspective. That's the things they care about for the safety of the operation. So what are the major deployment challenges? So those are the three things we can categorize, and then this exact thing CID is dealing with right now. One is stakeholder consensus. That's common to a lot of projects, right? In particular, in this type of project too, because it's new, it's unknown, especially if for agencies like CID, they rely on funding, working with Cobb County, ARC or GDOT. So they need to get everybody on board. So we are working with them, create opportunities to have the dialogue, maybe an education process. From design, so it's typical challenges associated with construction, right away, environmental impact, or any other things related to particular operation domain design. Can be where to furnish garage or charging locations. But the other major thing is funding. So we know to have a sustainable operation, you need to have a sustainable funding. So funding is one of the things that failed the other two deployment in the metro area. And that's something CID is also working hard to solve. And that's one of the main reasons they have to go to a phased approach. They get funding wherever they can get to work out each segment from right now, it's from a first phase alignment perspective. So I just want to highlight some of the typical funding opportunities. Like can be through research grant if you federal agencies, or can be economic development like City of Peach Corners. They are able to fund their own deployment. And with the CID agency, public agencies like that, we are helping them to sort out opportunities. Opportunities like a RAISE grant, SMART grant, those are potentially suitable for this type of deployment. So lastly, I just want to highlight what is coming up in this space from technology perspective. One thing we know is things are dramatically changing. One aspect is most manufacturers are foreign companies. So in the US, most deployments are using foreign vehicles. So you have to go through a kind of import exemption process. That's added challenge to the deployment. In about a year and a half from now, it's a major model you're going to produce in the US, going to be brought up by Holon. Is a German startup or startup company kind of spin off from the OEM parts manufacturer Benteler. They are working with Intel and a big AV operator, Beep Inc. from Florida. So they are coming out with a newer model, very much capable. The vehicle itself, it can run freeway speed, but from AV perspective, because the current version of the software limitation, they can top that at 35 miles per hour. But it's still dramatically improvement from the current model, most of the model we are running now. And the improvement can be in charging space, can be inside the space, can be more flexible. And also a lot of ADA compliance has been afterthought add-on. So in this newer model will be compliance will be built in. So that's it.